In this tutorial, we will create a segmentation from MRI images in ITK-Snap version 3. First, click on Open Image at the bottom of the screen. Select Browse to find your Nifty file, or whatever desired file format you have. It should automatically detect your image file format. Click Next. In each of these windows, you will see the superior to inferior view, the right to left view, and the anterior to posterior view. In the main toolbar, click Snake Tool. Click on Segment 3D, and on the right-hand toolbar, select Region Competition. Click Pre-Process, and here we adjust the threshold so that you can see the tissue of interest, but still filter out some noise. Once you've adjusted this threshold, you can hit OK. Adjust the bubble radius to anywhere between 2 and 3 units. Drag the cursor to a spot on the tissue, and then click Add Bubble at Cursor. I'm going to do this 4 to 5 times in the tissue, and then hit Next when I'm done. Now I can click Play and watch the segmentation be automatically created as the seeds spread out into the tissue. Once the segmentation does not change much anymore, I can click Finish. It is likely that you will have to adjust this segmentation. Scroll up and down to check a few things. First of all, the ventricle wall should not touch the septum as it appears to in this view. To fix this, click on the paintbrush, select brush size, and right-click to erase the mask. You'll most likely need to do this in several views. Secondly, you want to make sure that your segmentation does not exclude any tissue that you actually want. For example, you can see here that there's a chunk excluded from the segmentation. You can fill this in by left-clicking. Again, you'll most likely need to do this in multiple views. Lastly, you want to get rid of any part of the segmentation that might include background noise or artifacts. You can drag your cursor to a certain spot and then adjust your brush size. Then just right-click to erase the segmentation that you do not want. To see a 3D view of your segmentation, you can click on Update at the bottom left corner. Drag to see the segmentation in different views. If you want to save your segmentation for later, click on Save Segmentation Image, and you can save it as a Nifty file or whatever desired file format you want. Here, I'll save it as practicemask.nii. If you want to export the segmentation as a surface mesh, click on Export as Surface Mesh, click on Label 1, which is red, and you want to save as an STL mesh file. Here I'm saving it as practicesegmentation.stl. You're ready to export this segmentation into Blender. Next, we will import our segmentation file from ITK-Snap into Blender. We will start with a template 64-element mesh in a blend file. For now, you can ignore the template mesh. Next, click on File, Import STL File, and select your segmentation that we previously created in ITK-Snap. You might have to drag out the Import toolbar. Select your segmentation and click Import STL. The segmentation will probably be somewhere offset on the side of the screen. To scroll in and out, use the scroll wheel. To translate the view of the object, hold Shift and use middle click. In Blender, we will be using 2 views, Object Mode and Edit Mode. In Edit Mode, we are able to select vertices and edges, and in Object Mode, we can see the whole view. You can switch between the two with Tab. First, select All by pressing A, and go to Mesh, Vertices, remove doubles. Next, you'll want to press this button and select Face Select mode. Next, what we want to do is separate the data into different materials. This will make it easier to toggle which regions of the heart we see. Create 6 materials. The first will be gray, the second will be red, 3 will be green, 4 will be yellow, 5 will be dark blue, and 6 will be light blue. The first material we want to assign is red to the myocardium. First, estimate where the base is. We will assign everything from the base to the apex as red. I'm going to assign it here. In edit mode, hold down Ctrl and left click, and then drag to select faces. Go all the way around and select all the faces. Then click on Material 2 and click Assign. Now in object mode, you will be able to see that the myocardium has been assigned to red. To make sure that we got all of the faces, go back to edit mode, select all red materials, and hit the H key to hide only faces with this material. You can see that some faces did not get assigned to red, so I can fix that by selecting these and assigning them to red. Next, we want to assign the right ventricle to green. In Object View, if we would like to see the inner ventricles, we'll have to turn transparency on. To do this, go to Object, turn transparency on, and go to Shading. Select Material 2 and you can decrease the opacity. Now when we are in object mode, we can see through the myocardium to the inner ventricles. Next, assign the septum side of the right ventricle to yellow, after hiding the green faces. Next, we want to assign the septum side of the left ventricle to dark blue. If you ever make a mistake in selecting, you can always press Command Z, but if you accidentally assign a material to faces you did not want to include, just select them again and assign them back to gray. Lastly, it will be pretty easy to select the rest of the left ventricle and assign the faces to light blue. To see how you're doing, it's good to check object mode from time to time. And after you've finished that, then all the materials have been successfully assigned. The next step is to fit the template mesh to the data. We will want to keep the data in its original coordinates, so make sure that you move the template and not your data. You will most likely need to scale your mesh. In object mode, go to Object, Transform Properties. Hit Link Scale, and I'll scale mine to about 5 times scale. Next, you can use these buttons to help translate and rotate the mesh. We can use Translate Manipulator mode to move the mesh and Rotate Manipulator mode to orient the mesh. The easiest way to approximately line up the mesh is to line up the left ventricle. Line up the apex in the data to the mesh. It's helpful to play around with transparency so you can see what you're doing. You can also go to wire mode to help you line it up. You also want the right ventricle and other features of the heart to be aligned approximately. When you are happy with aligning the data to the mesh, you will want to isolate only the yellow, or the RV side of the septum. So toggle the transparency of the other materials so that you can only see the septum. Next, we want to make sure that this button, Retopo, is selected. Then click on this Snap button and make sure Align Rotation with Snapping Target is on, Vertex Select Mode is selected, and Active Object is selected. Now, when you right-click on a node, you can drag and manipulate it to snap to the data. Here we want to line up this side of the septum to the data. One helpful tool is to, on the mesh, unclick Transparent and click X-ray, which allows you to see the mesh through the data. Throughout this entire fitting process, you will want to ensure that you keep all of the elements close to being cubic, and that faces don't intersect. It's also useful to be normal to the side that you are manipulating. When you're done with this side of the septum, work on the other side. When you're done, check all materials to make sure that your elements are rectangular and capture the general shape of the data. Don't be too worried about local features. You mostly want to get the general shape right. Once you are done fitting, you are now ready to export your mesh into continuity. Before exporting into continuity, make sure that the location and rotation are set to 0. If they are not, go to Object, Clear Apply, Apply Scale Rotation to Data. Next, we will export the mesh into continuity. To do this, you will need to have installed the Hex Blender Python scripts. We can create a side tool by right-clicking this line and clicking Split Area. Change the window type to a Scripts window. Click on Scripts, Mesh, and select Hex Blender. These tools will convert element, node, and scale factor information into text files, which is a format that continuity can recognize. First, we will export the elements. Make sure that you have selected the mesh and not the data. Click on Hex keys and save this file. Next, we will export the nodes. To do this, it's important to make sure that you center the 3D cursor. Click on View, View Properties, and enter 0 for the 3D cursor. In Object mode, click Object, Transform, Center Cursor. Now click on Conti Vertex to save the file. This will export the node coordinates. Lastly, we will compute the scale factors, which will smoothen out the mesh. Make sure that you save your mesh first before completing this task. Go to the scripts folder in Blender and enter meshimprovement-functions.python. Command find hexinterp and comment out the original interp priorities and spline priorities, and change the numbers to 0, 1 in one group and 2, 3, 4, 5 in the second group. Make sure you save this, and then back on Blender, click on Scripts, Refresh Menus. Re-enter HexBlender and click on Interp Sub 2 times. The first subdivision will occur within a few seconds, but the second subdivision will probably take several minutes. Next, you can click on Tricubic Hermite to save the text file. Save this file as a new Blender file. We can also export the data to see how it aligns with the mesh in continuity. Again, make sure that the 3D cursor is centered and click on Conti Vertex, this time on the data. To prepare this for continuity, you will need to use the data template and copy your coordinates like this. Create a weight of 1 for all coordinates. Save this file. You are now ready to view your model in continuity. The last step is to now set up your model in continuity. Click on Mesh, Edit Coordinates, and select Rectangular Cartesian. Go to Mesh Basis, and click on Hermite 3D cubic, 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 add this, and select Lagrange, linear, linear, linear. Click OK. Next, go to Edit Nodes, Import Export Graph, click on File, Open, and import your nodes file that you exported using the Hex Blender scripts. In the Table Manager, click on File, Close and Update. Change all of the basis to cubic, 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 and change angle to radians. Click OK. Next, go to Mesh, Edit, Elements, and follow the same procedure to import your Elements file from Hex Blender. Make sure to click File, close an update form, and hit OK. Lastly, import your scale factors. To add your data, go to Fitting, Edit Data, Import Export Graph, and select your file that you saved in the data template. It may take a while to upload depending on how many data points you have. Now click on File, close an update window, OK, and you can render your mesh. Click on Send, Calculate, render lines first. If you can't see it, toggle your axis views, and you'll probably be able to find your mesh. We can also render the surface. Hit Surfaces, xi3 with a value of 0, and then again with a value of 1 to view these outer surfaces. We can also render our data points by going to Fitting, Render Data, and click OK. Now you have successfully imported your data and your mesh model into Continuity.